Assalamu alaikum wa rahmatullahi wa barakatuh. This video is video number 4 regarding design area. In another words, we called design area or area of operation or the remotest area. In any firefighting system, if we design, then we consider the remote area of that branch. That area we consider only in the designing. Suppose if we are designing any office and that office is light hazards. Suppose here example, if we take any example, see this is the building like 100 feet by 100 feet. Hundred feet by 100 feet. This is any building. We have to design firefighting system. I am not scaling the dimension and the dimension height, just this is only for example. This is any buildings. Okay, we have to design this building area is 100 feet by 100 feet. It means how many, if you take 100 feet by 100 feet, then it's a total 10,000 feet square for designing the firefighting system. In this area we have to design, but in designing we will not consider all this 10,000 feet square. Okay, if this building comes under light hazards, then we will consider only this 1,500. This area only we consider in the designing. Okay, if it is ordinary hazards, if it is ordinary hazards, then we will consider also the area of operation is 1,500. If it is extraordinary or extra hazard, we will consider the area of operation 2,500 square, and on this basis we will design all our firefighting system for that building. Okay, how to design and how we will place the sprinkler, how we will calculate all the pipe size, we will see in next video all. So if you are interested in designing, of course, if you are watching my video, then of course you are interested in the designing of the MEP system. I am not talking about only firefighting system. So if you are interested and want to learn more about the MEP system designing, then subscribe my channel and hit the like button as well as comment, so that you will get the notification of my every video. Okay, so now extraordinary hazard or light hazard, we will consider this 1,500 feet square for designing. So if this is 10,000 feet square, but we will consider only if our main branch pipe is here, then our remotest area will be this side. So we will consider 1500 area in this area only. We will design this area. On this basis we will design and size the pipe or place the sprinkler, everything on this area, on this basis of area. Okay, we will not consider all this area for designing. So area of operation we already understand that how it varies. Now let's talk about in as per NFPA. If we are designing the light hazard system, then in light hazard system area of operation is 1500. Okay, 1500 this area. So if we come state, then this is the light hazard system, so the density will be 0.1. okay, we will talk about in our upcoming video that what is the density and why we consider density. Okay, but here you have to understand that how we use this graph for the area of operation and determining the density. Okay, so if see here in extra hazard if we talk, then our area of operation is 2500 square. Okay, if we will come state in extra hazard group, then our density will be 0.3, right? So this is the method we consider the area of operation and the density. But now I am going to talk how it varies. We will not consider all the building the area of operation is 1500 or 1500 or 2500. Okay, it varies according to the shape of the ceiling. Okay, so if suppose this is the room, if ceiling height is 10 feet or less, if ceiling is 10 feet or less, and this is light hazard, and we are using the quick response sprinkler. How many types of sprinkler we use in the firefighting system, I will explain in details in our next video. But here we have to understand only that if ceiling height is 10 feet or less, and we are using quick response, there are many types of sprinkler: standard sprinkler, quick response sprinkler, ESFR sprinkler, but we will talk this sprinkler later in details. If this is quick response sprinkler and also wet system, if it is quick response sprinkler and wet system, then this area of operation will be vary according to this graph. So this graph is very important if we are using the quick response sprinkler. Design area reduction for quick response sprinkler. This formula is very important to consider the area of operation. What we do, generally we do take, if it is light hazard, then we consider 1500 for the area of operation, but it's wrong. If we are using quick response sprinkler, and the ceiling height we will also consider for the determining the area of operation. So if ceiling is, see here, ceiling height is less than or equal to 10 feet, okay, then if ceiling here, if ceiling is 10 feet, here ceiling is 10 feet or less, then it comes the reduction is 40%. This is the percentage reduction to design area. Okay, but how we consider? We have to remember this formula. Suppose if ceiling height is ceiling height is 10 feet or less, then the percentage reduction in the design area or remote area or area of operation will be 40%. Okay, so here you know that the area of operation is 1500 we consider for light hazard, but if we are using the quick response sprinkler and the ceiling height is 10 feet or less, then we will use this formula, we will use this graph or this formula to determine the area of operation. Now we see that if we are using a quick response sprinkler, then its reduction will be 40%. It means 1500 and minus 40%. Percent. Okay, it means minus 1500 multiply 0.4, it means 900. Then area of operation will be 900, but the density will be same. But the density, this density will be same 0.1. It will not vary. Only the area of operation will be vary. Okay. So here we will not consider 1500, only we consider 900 feet square. Okay. If the ceiling height will be more than, here it is more than 10 feet and less than 20 feet and equal to 20 feet, then we will also use this formula to determine the area of operation. Suppose I am going to design any building and that building comes under light hazard or light hazard, for example, and the ceiling height is 15 feet or 14 feet. So the area of operation, how much percentage it will reduce, we will consider. So here minus 3 by 2 multiply ceiling height is 40 feet plus 55. So our area of operation will be reduced by 34%. Okay, so 44%, it means our area of operation is 1500 for light hazard, but it will reduce 1500 by or 1500 multiply 0.34 510. It means 1500 minus 510. Our area of operation or remote area or design area will be this. This one 990 feet square. We will consider only this area, this much area, to determine our firefighting system or sizing the pipe or a sprinkler or whatever the things we will see in upcoming video. But in chart we see that area of operation of the light hazard is 1500, but we will not consider this one all time. If ceiling height, it's because this vary according to the ceiling height. If ceiling height is 40 feet or 50 feet or 19 feet, then we will use this formula to determine our area of operation. Now we got this point. If ceiling height will be more than 10 feet and equal to or less than 10 feet, then we will consider this formula to determine our area of operation. But for ceiling height is less than 10 feet, simply for ceiling height is less than 10 feet, then we will not calculate. In first example we see how to calculate, but if also it is less than 10 feet, then we will consider the 40%. We will consider the 40% reduction. And also the ceiling height is greater than 20 feet. It means 21 feet, 22 feet, 25 feet. Some building we see that ceiling height is 22 feet or 25 feet. Then the area of operation will be no reduction. It means if we are going to design the light hazard system, this area light hazard system, then if ceiling height is more than 20 feet and we are using quick response sprinkler, then we will not reduce or reduct the area of operation. We will consider the 1500 total to design our firefighting system. Okay. And next, in design area, this one we will consider later. But if we are going to design this building, we are going to design, for example, and the ceiling will be slope. If suppose like this, and our ceiling is slope like this, so, and also we are using the quick response sprinkler, and the system is firefighting system, but then reduction is more than 60 16.7%. Then we will consider this building as a slope ceiling. Okay, if less than 16.7%, it means the run, this is run, and this one is the rise, this is run and this is rise. If it is 1 inch rise and 6 inch run, it means from here 6 inch, and this is the 1 inch rise. In every 6 inch 1 inch is rise, then it will be more than 16.7%. So this type of structure we include as a slope ceiling. If it will be slope ceiling, then the reduction will be 30% without revising the density. Okay, so if this is the building, height doesn't matter, the ceiling height, it doesn't matter if it will be the slope ceiling. If it is slope ceiling, then the area of operation for light hazard is 1500. Okay, but this is the slope ceiling, so we reduce 30% directly. Okay, so our area of operation will be 1500. For our firefighting system, we include only 1050 feet square. Only we consider 1050 square. We will not consider 1500 fully. Okay, if this is the slope ceiling, then, and we are using quick response sprinkler or CMSA sprinkler, then we will reduce the area of operation by 30%. Okay, and also next, slope ceiling, this is the, but when we are using dry pipe or double interlock pre-action system or dry pipe, we in upcoming video we know that how many types of the firefighting system. It is very various type of firefighting system, like a wet system or a dry pipe system or double interlock system, pre-action system, many types of system we will see inshallah in our next video or upcoming video one by one. So if we are going to design this dry pipe or double interlock pre-action system, so without any revising the density, we will increase the 30% the area of operation. Suppose this is the building, and we are going to design not wet system, we are going to design a dry system. Okay, so, and this is the light hazard or any type of hazard, but we are considering here as a light hazard system. So we will increase the area of operation by 30%. So it means 1500 plus 1500 multiplied by 30%. So our area of operation will be now increased by 30%. It means 1950 feet square. We will consider now 1950 square area of operation or remote area for the designing our firefighting system. If we are going to design dry pipe or double interlock pre-action system. Okay, so and also if we are going to design high temperature sprinkler, it means not high temperature sprinklers we generally use in extra hazard. High temperature sprinkler we use extra hazard. If we are going to design extra hazard system, then without any revising the density, we will reduce the 25% of the area of operation. Okay, so here we see, here extra hazard is 2500 feet square. Okay, but if we are using the high temperature sprinkler, then we will reduce area of operation, we will reduce by 30%, 0.25%, sorry, 25% we will reduce. Then our area of operation will be to 1875 feet square. But the one condition is it should not be area of operation is not less than 2000 feet square. So it is coming 1875, but we will not consider this one. We will consider 2000 feet square for remote area. Okay, we will consider this 2000 feet square directly. We will not consider 2500 as per our this graph. As per this graph, area of operation 2500, but we will consider this 2000 feet square for the area of operation. Next, we will see, we are going to see this one. This is the extra hazard. Also it's same, that we in extra hazard we will not consider any area less than 2000 feet square as a remote area or as a design area. Okay, for also in previous example we see that if we are using quick response sprinkler, then how area of operation it varies. Okay, but for quick response sprinkler we use only use in light hazard or ordinary hazards. The quick response sprinkler we will not use in extra hazard. Okay, as per NFPA 13/2019, it's mentioned that where there are substantial amount of flammable liquid, we cannot use the quick response sprinkler. Okay, so now we already know that how it varies area of operation if we are going to design firefighting system, and we don't know about the area of operation, how it varies according to the ceiling or according to the ceiling height, ceiling structures, whether it is slope or more than 20 feet heights or less than 20 feet height, and type of sprinkler, which type of sprinkler we are using, then we cannot design the firefighting system effectively and up to the mark. Okay, so we want to design the firefighting system up to the mark. So we have to consider this example, design area reduction or this density curve graph. Okay, thank you very much.